Now let's discuss the Azure Key Vault. The Azure Key Vault is a cloud service used for securely storing and accessing secrets. So a secret is anything that you want to control, you don't want to have displayed in plain text, and you want to make sure that anybody who has these secrets are accounted for. So it's stuff like API keys, passwords, certificates, cryptographic keys, and these sort of things that you don't want to get out to just anybody. Key Vault supports two types of containers. It supports vaults and it supports HSM, or Managed Hardware Security Module pools. So let's take a look at the differences between those. So what is the difference between a vault versus a managed HSM pool? So vaults support software and HSM keys, secrets, and certificates, whereas a managed HSM pool supports HSM keys. So if you need more control over the hardware that actually stores your secrets, you want to take the managed HSM rule. That way you can manage the hardware behind where all your secrets are going to be stored. If that much compliance isn't needed, you can just use a regular vault and store your software and keys and secrets and certificates there. In order to use the Key Vault, the first thing we need to do is authenticate it. So there are three ways to authenticate to the Key Vault. The first being managed identities for Azure resources. In Azure, you can assign an identity to that virtual machine, and then that has access to the Key Vault. You can also assign identities to multiple other Azure resources. The beauty of this is that the app or the service isn't responsible for rotating the keys. Azure will automatically rotate the identity, and that's why this is considered to be best practice. You can also use service principals and certificates. So when you use a service principal and certificate that has access to the Key Vault, it's not overly recommended because the application owner or the developer is responsible for rotating the certificate, and this is not usually aligned with key compliance and security values of your organization. And finally, a service principal and a secret. So you can use a service principal and a secret to authenticate to the Key Vault. It is not recommended because it's really hard to automatically rotate the secret that's used to authenticate to the Key Vault because it's done by a bootstrapping mechanism. So that's not recommended. The managed identity for Azure resources is how we want to authenticate with the Key Vault itself. Key Vault roles that can be used to meet the needs of developers and security administrators. So the first is the Chief Security Officer's role. And so this role is good when you want to know that your applications meet all the compliance and regulatory requirements. Right? It's the most stringent of roles, and that's, you can see in the name, Chief Security Officers. We also have Azure application developers. So how do we approach developers and their interaction with the Key Vault? This role is great for if you have a developer who wants to write an application for Azure and use keys for signing and encryption, and they want those keys to be external from the application so they can distribute that application all over the globe. And finally, we have software as a service developers. So in this case, this role is great if you want customers to own and manage their keys, and you, as a software as a service developer, just concentrate on what you do best, and that's providing the core software features. So customers can import their own keys into Azure and manage them. And when a software as a service application has to do some cryptography using these keys, Key Vault does these operations on behalf of that software as a service application. Creating and using key vaults. So who can create and who can use these key vaults? Anybody with an Azure subscription can create and use key vaults. Now, Key Vault is mostly beneficial to developers and security administrators, but it can be implemented by anybody who has an Azure subscription. Next, we have administrators. So administrators are heavy users of the Key Vault, right? So Key Vault can be implemented and managed by an organization's administrator. So an administrator can sign in with the Azure subscription, create a vault for the organization, and then it's their job to create or import keys or revoke keys or authorize users to applications to access the Key Vault, right? And this could be someone's full-time job, or at least a part of their duties as a security administrator. And finally, developers. So developers can manage the keys directly by using API calls. So they can incorporate the key into their application by making API calls to the Key Vault itself. Now let's discuss Azure Private Endpoint. So what if you want to make sure that your data doesn't traverse the global internet? Azure Private Endpoint can do just that for you. So private and service endpoints are used for making sure that data flows only within your private link. So Azure Private Endpoint is a network interface that connects privately and securely to a service provided by Azure Private Link. So the private endpoint uses a private IP address, so we definitely cannot send that traffic out over the internet using private addresses. It's secure and private because, again, we're just sending traffic using these private IP addresses from your virtual net or your VNet. So we're effectively bringing the service into your VNet. This service can be any of the Azure services. This could be Cosmos DB. This could be an Azure SQL server. It's completely up to you, but whatever data that you want to make sure doesn't go over the web, you want to incorporate private endpoints. Some features of private endpoints. So, local or remote connectivity. We can connect with consumers in the same VNet, VNets that are peered regionally, or even VNets that are peered globally over the whole infrastructure. We can also use it with VNets that are peered with on-premises using express routing or VPN. Connections are initiated by endpoint users. So these network connections can only be initiated by clients who connect to the private endpoint. Service providers can't route into these private endpoints, so connections can only be established in one single direction. And again, that ensures the security that we're looking for. Our network interfaces are read-only, so it's created for the whole life cycle of the resource, and that interface is assigned dynamically in a DHCP fashion from the subnet that you've created. So the value of that private IP address is unchanged for the whole life cycle of your resource. So you don't have to make changes to your private endpoints every time a private IP address changes. That wouldn't be good design. And finally, the private endpoint must be deployed in the same region as the VNet or the virtual network. Let's look at some more private endpoint features. So the private link can be deployed in other regions that are different than the virtual network and the private endpoint. Private link can be used to create multiple private endpoints. So for a single network that has one DNS server, for example, it's best to use one single private endpoint for a given private link, and that'll avoid duplicate entries into your DNS server. Multiple private endpoints can be created on different subnets that are within your same VNet. And private link subscription must be registered. So the subscription for the private link resource must also be registered with Microsoft. So that's some things you have to take note before you use this feature. Some other private endpoint considerations that we need to look at. First of all, being private link resources. So what is a private link resource? A private link resource is the destination target of a given endpoint. So whatever the end resource is of our endpoint, that's our private link resource. So what are we trying to hit over our private endpoint? Network security of private endpoints. So when we're using these private endpoints, the traffic is secured to a specific private link resource. The platform performs an access control to validate network connections. So it goes down through an access control list and checks the accepts and denies, and approval workflows. So to gain access to a private link resource using an approval workflow, you can connect to the private link resource automatically. So it's approved when you own or have permission to a specific private link resource, or manually if you have to request it and you don't automatically have that approval. VNet service endpoints. So a VNet or virtual network service endpoint provides you with direct, secure connections over the Azure backbone. So it provides you with optimized routes over that Azure backbone, and it incorporates private IP addresses that can reach these endpoints. So for VNet to reach the endpoint of an Azure service without needing a public IP address, it needs this private IP address. So this allows us to make sure that all our critical resources are only accessed through our virtual network. Right? So we're kind of expanding that and bringing these resources into the virtual network. And that way, no traffic that doesn't originate from our virtual network can hit these service endpoints. Some service endpoint features. So endpoints always take traffic directly from our virtual network and forward it to the Azure backbone. So we're not sending any of their traffic out over the web. And that's really important, especially when it comes to securing your data and compliance. We can also monitor outbound internet traffic from our VNets. That'll allow us to see what kind of traffic is leaving our network and if it's anything that we should be interested in, right? So that it's good for auditing. And this has no impact to service traffic. So through forced tunneling, we can monitor our outbound traffic and still not have any effect on that service level to our end users. Some more service endpoint features. It's very simple to set up, and you don't have any more overhead. You don't need reserved public IP addresses in our VNets anymore because we're not sending our traffic out to the public internet. So as a result, we don't need a NAT server anymore either, or any gateway devices. Right? We can just configure our service endpoints through a couple clicks in the console, and there's so much less overhead at the end of the day. We're not dealing with public IPs. We're not dealing with NAT devices. Some advantages of service endpoints. First of all, you have better security. Right? These VNet private address spaces can sometimes overlap, and you can't use overlapping spaces to uniquely identify traffic that originates from your VNet because you don't know, it overlaps. You can't really tell if it originated from the VNet. So by incorporating these service endpoints, you can now secure your resources to your virtual network. So you're basically extending that VNet identity to the service. And on top of that, we've got optimized routing. So any routes in your VNet that force internet traffic to, say, your on-premise data location or any virtual appliances, that makes Azure service traffic take the same route as the internet traffic. Service endpoints provide the optimal routing for Azure traffic. So by using these Azure service endpoints, we're taking the optimal route, which is going to decrease our traffic time and our latency. So better security, optimized routing. Two fantastic advantages of using these service endpoints. Some things to look at when using service endpoints. Provisioning. So they can be configured on VNets independently. To secure our resources to a VNet, you as a user must have the appropriate permission. So you need to be included into an administrator role that can allow you to provision secure endpoints. Secure Azure to virtual networks. So a VNet service endpoint will provide the identity of our VNet or our virtual network to the Azure service. Once we enable these service endpoints in our VNet, we can add a virtual network rule to secure these Azure service resources to our virtual network only. So we're keeping that traffic internal. And you can secure Azure from on-site. So by default, Azure service resources are secured to virtual networks and they aren't reachable from on-premises. So if you need your traffic to go from your on-premise data center, you must allow public IP addresses from your on-premises or using Azure Express Route. You can add these IP addresses through the IP firewall configuration for your Azure service resources. And some caveats. This feature is only available to virtual networks deployed through the Azure Resource Manager deployment model. Endpoints that are enabled on subnets configured in Azure Virtual Networks. So endpoints can't be used for traffic from your premises to Azure services. And for Azure SQL, a service endpoint applies only to Azure service traffic within a virtual networks region. So before you get in and start deploying these service endpoints, get in and make sure that, these caveats don't pose a problem for you. In this video, I'm going to show you how to use a managed virtual network along with private endpoint to connect your Azure Synapse Workspace to other services in Azure. And the service I'm going to use is going to be a data lake. So I'm going to connect the Synapse Workspace to the Data Lake Storage Gen 2 account and look at some of the data over the private link. So the first thing we need to do is come into Azure Synapse Analytics. And we're going to go ahead and click Create. So once we're in our Synapse Workspace console, we click our subscription and any resource groups that we've created. Then we have to give it a name. So I'm going to call this Richard Secure Demo WS for Workspace. I'm going to put it in US East 2. And I have to remember that. It's important that we put our resources in the same region. Here I get to create a Data Lake Storage Gen 2 account. I can use one if I already created one. I don't. So I'm going to let the Synapse Workspace console create it for me. So under account name, I'm going to click Create New. And I'm going to call this Richard Secure Gen 2. And then I have to create a file system name. So I'll call it Richard Secure FS for file system. I'm going to assign myself the Storage Blob Data Contributor role, and I'm going to click Next on Security. Your admin username is SQL Admin User, so type in a password. Make sure it meets all the requirements. We can scroll down. We can enable double encryption if we wish. In this case, we don't really need to for the demo. Click Networking, and here's the important part. You want to make sure you click Enable Managed Virtual Network and only allow outbound data traffic to approved targets. So basically what that's telling us is that we're going to use private endpoints to connect to other Azure resources. So I go ahead and click Next on Tags. Click Next to review. Validation has succeeded. And now we wait for the creation. So we've got to create the Synapse Workspace. It's also going to create the storage account and the file system as well. So it could take upwards to maybe 10 minutes. So now you can see the deployment is completed. Right? It's created the storage account. It's created the workspace. So now let's go into our Azure Synapse workspace. So I'll come up, type in Azure Synapse Analytics, and we'll see the Synapse workspace we just created. So we can look at our workspace web URL. It's here. But I also want to go back to the storage account. So let's go back to our storage account. Find the storage account we created. Click it. Then come down to networking. So it's imperative that we set this up to enable private endpoints. So under firewall and virtual network, we can leave this the same. But under private endpoint connections, I want you to create a private endpoint. So again, you have to create your private endpoint by supplying a subscription, your resource group, change your region to US East 2, and then give it a detail name. So I'm going to call it Richard Storage Private Endpoint. Click Next. It's asking me what my target sub-resource is going to be because it knows the resource is a Gen 2 storage account. So I'm going to click Blob, click Next for configuration. We have to deploy it to a virtual network. So you have to create your virtual network, then come down and make sure it's integrated with a private DNS zone. And then you'll see your new private link DNS zone here. So click Next for tags, click Review and Create. Validation has passed. You're creating a private endpoint now for your storage account. It doesn't take too long to deploy. Deployment has already succeeded, so it was relatively quick. Our next thing we have to do is come back into Synapse Analytics, open up our Synapse workspace, come down to your workspace web URL, and let's open up that workspace. So now I'm in my workspace. Come down to Manage, and you'll see Managed Private Endpoints. Go ahead and click Manage Private Endpoints. You'll see two that are already there upon creation. We're going to add a new one, and that's going to be the endpoint to our storage account. So click New. Choose Azure Data Lake Storage Gen 2. This is the name we're going to give it, Azure Data Lake Storage 1. Our account is going to be from our Azure subscription. Make sure you select the appropriate subscription. And then the storage account name that we created earlier should automatically be there in the drop-down. So we click it. We click Create. And now it's provisioning. So there's two steps. It has to provision the private endpoint. Then you have to go over to your storage account and approve it. So if we click it, we can see that it's succeeded in the provisioning, but it's in approval state. So let's go back to our storage account. So I come up, click Storage Accounts. Come back under Networking. And click Private Endpoint Connections again. Now you'll see the one that we just created from the Synapse workspace, and it's pending. So click the box and approve. So do we want to approve the connection? Yes, we do. We can add a description if we want. This takes a couple of minutes. So in the meantime, I'm going to go down to my containers in my data lake storage. I'm going to go into my secure file system, and I'm going to upload a CSV file. Now this CSV file was used for a machine learning operation, but the content doesn't really matter. But it is a CSV file that we can kind of pull up in Workspace and have a look at. So that's uploaded. Let's head back to our Synapse workspace. Now we're going to come back and we're going to come to Home in our Synapse workspace. Here's where we can ingest data, explore and analyze, visualize our data. Or I can come just down here to Data, and you'll see linked services. So if we click Link Service, we'll see the Azure Data Lake private endpoint that we just created. You'll see the secured demo workspace. Then you'll see the secure file storage. Once we click here and open it up, sure enough, we see the CSV file that we just created. And from here, we can create a SQL script, create a new data notebook. We can ingest that data set, or we can upload more. But the point is that we're working on our storage account through Synapse Workspace all over a private endpoint. And you can tell that because it's linked. And if we wanted to edit, just to not really edit, but just look and be sure that we're using that endpoint, under this link service, you'll see that we are indeed using a managed private endpoint, and it's approved to a link service. So I hope this video showed you how to create a Synapse Workspace, create a storage account, and then use private endpoints to control your storage account from your Azure Synapse Workspace. And all of this data is being sent privately over your own account and not out over the internet. Now let's dive into Azure Managed Identities. So a common issue when developing applications in Azure or any cloud service is the managing the secrets and credentials used to secure the communication between all the different services that make up our application. Most cross-service integrations in Azure are done either via secret keys or a token exchange. Token exchange is a much better approach because it's done using Azure Active Directory. So now developers have much better control over security, lifecycle, and permissions of their application. Managed identities will now eliminate management of secrets and credentials. It's not something you as a developer have to worry about anymore. It provides Azure Active Directory identity. So Azure AD allows creation of something called a service principal, which in layman's terms is simply an application user. And any kind of user in Azure, regardless of its type, is called an identity. So it's important to remember this because identity is a word very often mentioned in documentation and in the Azure portal. Typical user consists of a client ID, so this would be a username, and a client secret or certificate. Once we provide that identity for the Azure resource in Azure AD, we can now use that to obtain Azure AD tokens. This also helps accessing the Key Vault, where developers can also store credentials in a more secure manner. Some types of Azure managed identities. There are two types of managed identities. The first is system assigned. So some Azure services will allow you to enable a managed identity directly on a service instance. When you enable this system assigned identity, is then subsequently created in Azure AD, and it's tied to that resource for the life cycle of that resource. You also have user assigned. So if you, as an administrator, create a managed identity as a standalone Azure resource, then you can assign it to one or more instances of an Azure service. System assigned versus user assigned identities. So when it comes to creation, a system assigned identity is created as part of Azure resource. So if you're spinning up a Cosmos DB, then you may have an opportunity to create a system assigned identity at that time. A user assigned is when you as an administrator create it as part of a standalone Azure resource. The system assigned lifecycle is shared with the Azure resource and connected to a managed identity, and then it sticks with that resource for the full lifecycle of the resource itself. User assigned has an independent lifecycle, so it doesn't hang with the resource for the whole time. It's not connected to a managed identity. And system assigned identities with regards to Azure resource sharing can only be associated with one single Azure resource, whereas user assigned, it's shareable. So you have that advantage of being able to share user assigned identities, but they're also independent of the life cycle of the resource. So it really depends on what you really want to accomplish. So regardless of the type of the identity chosen, a managed identity is a service principal of a special type, and it can only be used with Azure resources. So if you have a third-party resource, you will be forced to use the user-assigned identity. Advantages of Azure Managed Identity. First of all, no credential management. You don't have to worry about it. You can't even see them anymore. Okay, so we're not storing usernames. We're not storing passwords. That is gone. It's a thing in the past. Any Azure service supporting Azure Active Directory Authentication can use this, even the Azure Key Vault itself. And managed identities can be used, and it doesn't cost any more money, so it's no extra cost. So implement this, make your life easier at no additional cost. Seems like a really no-brainer to me. So what services can we integrate with managed identities? Some of these services are the API management, Azure App Configuration, the App Service, Auto Manage, Blueprints, Cognitive Search, Azure Communication Services, Azure Container Services, Azure Firewall Policy, IoT, Import-Export, Kubernetes Service, Log Analytics, Machine Learning, Policy, Service Fabric, Stack Edge, and Azure Virtual Machines. So using these managed identities, you can authenticate to any of these services. In this video, I'm going to show you how to implement POSIX-style ACLs in your Azure Data Lake Gen 2. So let's go into the portal and click on our storage account. So these POSIX-style ACLs give you a little bit more of a granular access control, and access can be applied down to filters and directories, much like Windows and Windows ACLs that we're used to using in a Windows environment. Access can be granted to Active Directory objects like users, groups, service principals, and managed identities. And default ACLs can be applied to new files and folders that are added to a directory. So once we're into our storage account, let's choose our storage account that we want to implement the ACLs on. I usually push this to the side, and now I'm in my storage account. And this is a Azure Data Lake Gen 2 because it has a hierarchical namespace setup. So the first thing I want to do is come in and open and explore. And it's going to ask us to open the Azure Storage Explorer. I click Allow and Open. And this should bring us into our Azure Storage Explorer. If you don't have it, you'll want to download it. It's easy to get. It's just on the Microsoft website. It brings me into my storage account. So you'll see all the subscriptions that I have here. And I want to work on the Richard Spencer Azure Data Lake Gen 2. You'll see my blob containers, my file shares, queues, and tables. If I look at my blob containers, you'll see I have a file share with more Excel spreadsheets. So I'm going to apply some ACLs to the blob containers. So I want to right-click on the folder, and I want to say Manage Access Control Lists. So you'll get a pop-up that comes up. Here's where you manage your access control list. So you've got users, groups, and service principals. These are your Active Directory objects. You can come down through and you can see the permissions. And then we can also add one. So if I want to add, so I can search for an entity. So if I type Derek, I get a bunch of names back. So I can pick one guy that's part of my team. I can add him. And it asks me for permissions. So I can give him access permissions of read and write. And click OK. I can come back into Manage Access Control Lists again. And now I can add someone else. So if I search for myself, I get an entry back. I click Add. And maybe this time I get read. So I click on access, and I take read, write, and execute, and click OK. So it successfully saved the ACL. And now if I look at Manage Access Control List again, I can come back in and I can see all the activities that the super user can do, the super user of the owning group. Anyone else don't have any access. There's permissions for mask, so it's read, write, and execute. And we've also got two users, one with read and write, the other with read, write, and execute. So I'm happy with that. I click OK. I can right click, I can propagate these access control lists. So we're propagating these ACLs of the directory, and they'll be propagated to all the existing children directories. So I click OK. I understand that propagating ACLs cannot easily be reversed. I click OK. I don't have any children directories there, but it says it successfully propagated ACLs. Directories changed. 1, files changed. 2. If I had any children directories here, it would be propagated out to those children directories as well. So I hope this video showed you how to implement these POSIX style ACLs into your Azure Data Lake Gen 2, because it gives you the most granular style controls to your data lake. In this video, I'm going to show you how to implement role-based access control in your Azure Data Lake Storage Gen 2 account. So once we're in the Azure portal, I want to come up to Storage Accounts, and I want to find my Azure Data Lake Gen 2. So Storage V2, and it's Richard Spencer. So I'm going to go ahead and click that storage account. Collapse the left-hand side so I can see everything. And now we're going to use role-based access control. So we're doing access control. It's more coarse-grained. Basically, we're setting people up into roles, and we're assigning roles permissions to specific aspects of our storage account and our data lake. So if I come down to access control and click access control, it'll open up in a new window. You'll see a few tabs. So we have check access, role assignment, roles, a preview of the new roles, deny assignments, and classic administrator. So the first thing we want to do is look at the roles. So let's click roles, and this will load all the roles that are built in with Azure. So a role is just a collection of permissions, right? We can bunch up a bunch of permissions and put it into one role, and then assign roles to end user. So think about this before we actually get into it. If we had people who only needed access to data regarding log files, they were server admin, we could create a role called server admin, give that role permissions to access server log files, and then assign that role to our server administrators. So if we look at some of the Azure built-in roles, we've got owner, contributor, reader. We've also got things like backup operator, log analytics contributor, managed application reader, and again, these are all out-of-the-box roles. Storage blob data owner, virtual machine contributor. So there may be roles there to fit your needs right away. If there isn't one to fit our needs, we can create a new role using PowerShell or the command line. Basically, we just need to find out what permissions we need, give it a name and a description and an ID, and what the assignable scopes are, so what they're able to do. So if I want to look at one of these in Notepad, it kind of looks like this. So this would be our custom role, right? This is virtual machine operator, can monitor and restart virtual machines. Here are the actions it can do on these scopes. So you're bringing in the services that you can do these actions on and under what subscriptions. So we can change this to fit our needs. It's customizable as well. So I'll close that. I'll come back to roles. We've seen the roles. We've seen how to create a custom role. So now I come back to role assignments. I can change the scope for just this resource. And you'll see I have some role assignments. So I am right now an owner. And I've got 2 users who are just readers. So if I come back up and I want to add a role assignment, I can select my role. So I'm going to say this user is a site recovery operator. I can assign this to a user, a group, or a service principal. So it doesn't have to be just a user. It could be a service principal as well. Right? Something like the function app or a logic app or a virtual machine. In our case, I'm going to assign it to a user. And I'm going to search my name. It brings back my name. I click Save. It adds my role assignment. So now I do a refresh. I look down under Site Recovery Operator. I'm here as well. Right? So with Site Recovery Operator, if I click that role, I can see all my permissions. Right? I can read Get Administrator. I can read Get Administrator Operation statuses. So really what we're doing here is it's a more coarse approach, but it's easier for implementing. So you create your roles and then you assign your roles to users. And when new users come on, we just assign them a role and they inherit those permissions. We can look at the permissions here. We can look at them in JSON. We can look at them from the assignment. So who are the site recovery operators? So it's a little bit different than doing it from an ACL perspective, but it's also a little bit easier to implement as well. So if I come back into access control again, I can also view my access. And it shows me all my roles and what I can do. I can view access to this resource and it shows me all the roles and what these people can do. So the Check Access tab is a great way to make sure that your roles are given the appropriate permissions, not too much and not too little. So I hope this video showed you how to use role-based access control to look at the actual roles that are deployed with Azure, to create custom roles, assign these roles to users, and then check user access. So get in, start playing around with this role-based access control, and make your access control administration a little bit easier and much more flexible to use. Now let's take a look at using REST API authentication with Azure Databricks. To authenticate to the Azure Databricks REST API, all you need to do is create a user-generated personal access token and include that personal access token into your API request as a bearer header. These tokens come with an expiration date, that's optional, and revocation. So you can make a token expire after 7 days, or you can revoke a token easily if a person no longer works with the organization or don't need access to that Databricks workspace. So these are great for temporary access. You can have a maximum of 600 tokens per user per workspace. So you should never run out of available tokens. There are plenty to use, but it gives you a much better way than just using username and passwords when you connect and make API calls. Let's incorporate these tokens because they expire if we want them to, and we can revoke them. So it's much easier to manage. So default token creation privileges. Who can create tokens? All users can generate tokens in your workspace. This is enabled by default for all users in your Databricks workspace. These users can set any expiration date that they like, and they can generate these tokens And it can be even for an indefinite lifetime if they wish. So by default, out of the box, the ability to generate personal access tokens is enabled for your workspace for all users in your Databricks workspace. Workspace administration and tokens. So the ability to use personal access tokens is enabled by default, like we said, for all Azure Databricks workspaces that were created later than 2018. But workspace administrators can also do so much more. These workspace administrators can monitor tokens. They can configure token creation privileges, so who can create tokens, right? Do we want to allow all users to create tokens? Do we want to lock that down to, say, just security administrators? And they can establish a token lifetime. So they can set maximum lifetimes for new tokens. So if a new policy comes in and says, our max lifetime for a token is now 30 days, then you can also make this configuration change as well. Azure Databricks Administrative Control. So as an Azure Databricks admin, you can use the Token Management API and the Permissions API to control token usage at even a less coarse and one would say a more fine-grained level. There are some tasks that you can perform using the admin console. But again, for that more fine-grained approach, you want to use your Token Management API and your Permissions API as well. Token Task Management Tools. Like, what tasks can we perform using the web application and what can we perform using the REST APIs? So in the admin console, we can enable and disable tokens. We can also do that with the REST API. We have user token access in both the admin console and the REST API. But here's where you start noticing the more higher capabilities of the REST API. You can set a maximum token lifetime. In the REST API, you cannot do that in the admin console. And you don't have that token management and that fine-grained token management in the admin console that you would have in the REST API itself. So get in and learn how to use the REST API and you can really take advantage of the tokens to secure your Azure Databricks workspace. In this video, I'm going to show you how to invoke Azure Databricks APIs using personal tokens. So the first thing we want to do is go into Azure Databricks, create a workspace if you haven't already. I've created mine. It's called Databricks RS. So I'll click it and it brings me into the console. First thing I want you to notice is the URL. So copy this URL, put it in Notepad. We're going to need that URL to make API calls. Okay? So once you've copied the URL, click the URL and it will bring us to our Azure Databricks workspace. Once it loads up, you're into your workspace. Come up to the top right-hand corner where you see the name of your Databricks workspace. Click it and go to the admin console. So once you're in the admin console, click Access Control. And if you scroll down, you'll see a section that says Personal Access Tokens Enabled. This needs to be enabled in order to allow users to use access tokens to make API calls with Databricks. Ours is enabled. If you wanted to disable it, you could click Disable here. We won't. And you can also configure permission setting. So who can manage and who can't manage tokens, who can create new tokens. So right now, admins can manage. If I had a user and his or her job was just to create tokens and revoke tokens, I could probably create a group called Token Administrators, put these people into that group, and then give that group the appropriate permissions here to create and revoke tokens. I can leave it alone because mine is fine. I'm an admin and I can manage tokens, so I'll leave it as it is. Next, come back up to your Databricks again, up in the top right-hand corner, and click User Settings. So under Access Tokens, here's where we get our tokens. So I'm going to click Generate New Token, and I'm going to call it Richard Temporary Token, and I'm going to give it for 7 days. And that's the beauty of tokens, is that they will automatically expire and revoke after, in this case, 7 days. So if we want to give a user short-term access, tokens are our answer. So I click Generate. It generates the token. And you want to copy it right now because you won't see it again. So copy this token, put it in your notepad somewhere safe. Click Done. So now I have 2 tokens, a Richard Temp token and a Temp access to Databricks. Here's where we can revoke tokens. So I click the X next to the one I want to revoke. It says any applications or scripts using this token will no longer be able to access the Databricks API. We can go ahead and revoke the token. So now I've got my workspace URL copied. I've got my token copied. Let's send an API request. I'm going to use Postman. You can feel free to use whatever you wish to make your API requests. So once I'm in Postman, you can see I'm doing a GET request. Here's the URL of my Azure Databricks workspace. And I'm using a request on the API 2.0 clusters list API endpoint. And that's fine. But we want to incorporate our token. So under authorization, we want to include a bearer token. So it's sent with the request. Now this is the token from previously that we just revoked. So if I send this API request using an old token, it comes back and says error 403, invalid access token. So I'll get rid of the old one. I'll put in the new one. Send it again. This time, no error. Okay, so I successfully made that API request using my personal token, which I sent as a bearer token with my API call. If we had absolutely no token whatsoever, you would get an error unauthorized. So that goes to prove that our token is working and we can continue to make API calls. So I hope this video showed you how to create tokens, revoke tokens, manage who can create and revoke tokens, and then make API calls to your Azure Databricks workspace using the bearer token that you've created. So get in, create some tokens, especially for temporary users, right? And if you're using the username and password method, try and get in and use the API method and start generating some user tokens and start calling some Databricks APIs using your user token. In this video, I'm going to demonstrate how to create a retention period for temporal tables in Azure SQL databases. So the first thing we need to do is log into our SQL Server using SQL Server Management Studio from Microsoft. And under databases, you'll see I have a database called Website DB. So temporal tables are easy to manage the history because we only need to add one parameter in. So I have a query here that's going to create a table for me. It's going to create a table called Website User Data. It's going to bring in a user ID, a username, the pages visited, valid from, valid to, the period, which brings in the valid from and the valid to, and it's going to turn on system versioning. The history table is dbo.websiteuserDataHistory, which is automatically created with the default settings. And the parameter for retention is the history retention period, which is set to 6 months. So from here, I'm going to use this website user data table to store data about visits to my website. So I'm going to execute it. Query executed successfully. So I'm going to come over to my website database. I'm going to do a drop down and I'm going to refresh. And now I should see under my website DB, and you can do this with any database you create, right? Because these retention periods are set at a table level. So any table that you have, you can do this with. And I'll show you how to modify existing tables to set a retention period as well. So we have website DB. I expand tables. Now you see my website user data table. It's a version system table. You can tell because it has the clock icon. I expand it again. You see the history table is here. So right now, this is our table. It's a temporal table, so it's tracking changes to the database, and it's only going to keep that data for 6 months. I can change that as well. So I can alter a table. So if I already have a table that I want to enable versioning and I want to set a retention period to, I can alter a table. In this case, I'm going to alter the previous table I created, website user data, to set system versioning on, which it already is, but I'm going to change the history retention period to 1 year. So we can use retention periods and we can use days, months, and years. So right now we're at 6 months. If I execute this query, it completed successfully. Now we're retaining our data for 1 year. I can even change this to 1 day. And I execute it and I change the retention for 1 day. So it's that simple to create a retention policy. Right? We only need that history retention period parameter, and we can specify X number of days, months, or years, depending on how long you need to keep your data. These temporal tables, the history grows, right? Especially if you have a database that makes a lot of changes and modifications. These history tables are going to grow, and they're going to grow exponentially. So you want to make sure you have the properly fine-tuned retention period, so you're not storing data you don't need, but you're also not storing data that you do need. So I hope this video showed you how to create a temporal table retention policy and get in and make this work for your existing databases. Because again, it's only a simple modification that you make, a simple alter table statement. You can turn on system versioning and you can change the retention period at will. So again, get in, play around, and use this on your databases because it's a great feature from Azure SQL databases. In this video, I'm going to show you how to implement auditing on your SQL database in Microsoft Azure. So once you're in the Azure console, come up to SQL databases, and you'll get a list of all the SQL databases that you have running. So the website DB is the SQL database that I want to enable auditing on, and it's hosted on the Richard SQL server. So I'm going to click this database and collapse the left-hand side. Now I can see my server, my database, and all the other attributes. We're interested in auditing. So on the left-hand side, under Security, choose Auditing. We click Auditing, and you're brought into the auditing console. So 2 things to note. An auditing policy can be defined for a specific database or as a default server policy. So if you do it as a default server policy, so server level auditing, which right now for us is disabled, if we enable it, it applies to every database on that server, regardless of the individual database auditing settings. So let's take a look at server auditing. So if I click server auditing, you can see that I've got an option here to enable Azure SQL auditing. And it gives me a log destination. So where do I want to store my logs? I'm going to choose storage, and I'm going to choose my storage account. I could also log it in the Log Analytics service or in Event Hub. If I expand advanced properties, you'll see there's a retention period. So how long do I want to retain these SQL audit logs. I'm going to go ahead and say 14. And you'll notice that you can also audit Microsoft support operations. So it'll track the support engineers or Microsoft's DevOps teams and any of the operations they do on your server. So if you want to enable that, you can enable it. And you can automatically choose a different audit log destination is chosen for you. Or you can deselect it and use the same storage account to send the logs to, as we did with the regular database auditing. So I'm going to click Save, and that should save the settings on the server. So every database now, regardless of what we said, will inherit these auditing settings for the server. So once this saves and is completed, it'll bring us back to the database, and we can look at it from a database perspective as well. Much of the settings are still the same. So if I come back to my database, click OK, you'll see server level auditing is now enabled. And it's enabled here in the database as well. If I turn it off here, for this database, it's still enabled for the server, so it's still going to be logged. All right, so there's two ways. If you do it from a server perspective, it's logging everything and every database on that server. But if you leave server level auditing disabled, you can just audit your SQL database individually, whatever you really want to audit. So I hope this video showed you how to implement auditing for your SQL databases, because this auditing is very important because it tracks database events and then it'll write them to our logs. This helps us maintain regulatory compliance, understand any database activity if we need to troubleshoot, and gain insights into discrepancies and anomalies that could indicate business concerns or suspected security violations. So make sure you go in, look at your auditing, right? Make sure you make changes, and when you're done, you can click View Audit Logs, and it'll bring you into any audit logs that have been created for this database. For the database, or you can get it from a server level as well. So we haven't made any changes. If we were to make changes to the SQL Server or the SQL database, you can, with one click, go in and see the audit records, see who the principal name was, the event type, and the action status that they tried to run. So again, get in, enable auditing, and take a look at these audit records to give you some really good insight on your database server or individual database level. So in this course, we've discussed how to secure your data access. We did this by talking about how Azure Key Vault is used. We discussed private and service endpoints. And we talked about and implemented using managed virtual networks and private endpoints. We also discussed how to use Azure Managed Identities. We then went on to look at how to manage access control lists and using Azure Role-Based Access Control, Azure Databricks and token-based authentication. Then we looked at temporal table retention policies and auditing in Azure SQL Database. In our next course, we'll move on to examine how to utilize tools to secure data in Azure Blob Storage and SQL databases.